The book we're talking about is how big is big and how far is far.
Right.
And we came up with this idea to fill a hole where people were making these models of systems, but our models were classroom-sized. We also have a model that's playground-sized, but it's nothing like the size of the solar system. So a book to bridge the connection between the models we're using and the real thing, how big is big and how far is far, starts with terrestrial objects. Whales, big whales and small whales, but a small whale is bigger than a big bat. And then there are small bats. So is a big bat big? Not when you look at a whale. What about moons in the solar system? There are small moons, which if we set one down in this room would be big. And after you do big and small, there's near and far. A lot of people travel far to get to school, but that's nothing like how far it is from the Earth to the Sun, or from the Sun to Neptune. So we have a variety of diagrams, comparisons, tables, to help people synthesize these ideas and get some idea that the universe is awesomely large.
And you know, this book actually plays several different roles. It provides important content and conceptual ideas about size and distance in space, but it also has data tables that students need to interpret. So there's some what we call secondhand investigation there, where students are really inquiring into the text and figuring out, based on data, that Mercury is really far, but Neptune is really, really, really far, based on their analysis of these numbers here.
Are those the technical terms?
Yes. Super majorly far, that's the technical term.
Okay.
But also, this book does a lot of things. It also, there's a lot of modeling of comparative language and making claims about things that are near and things that are far, and how to back up those claims with evidence. And it does other things too.
Well, and I love at the end of the book, we actually sort of present to kids, instead of kind of trying to gloss over the fact that you can't really have a completely accurate diagram of the solar system. So, we show them, okay, this diagram shows the relative size accurately, and then this diagram shows the distances accurately, but you really can't do that, in the same diagram, because it just, it would be a diagram the size of a football field or something, and the smallest planet would be the size of a period. So it's just, I think it's really fun that they get to grapple with those concepts.
Yeah, and it really helps them evaluate, information that's presented visually, and sort of say, okay, well, what's accurate about this and what's not accurate about this.
They see diagrams like this all the time,
Yeah.
without being told that this isn't really the way it looks. We have to show it this way to make it understandable. But there's more to understand than what is just shown here.